surface of the sea, the water is cold and in perpetual darkness. Less is known about the floor of the world's oceans than the surface of the moon. It is only in the past few decades that scientists have been able to explore this deep underwater world using remote-operated vehicles, or ROVs, and revolutionary manned submersible craft such as the Jago. For the first time, it's enabled scientists to see, with their own eyes, what lies in these murky depths. One of their most startling discoveries has been the abundance of coral reefs, living hundreds of meters below the surface of the sea at around 4 to 13 degrees centigrade. What's more, many of these reefs seem to play a significant role in the health of sea life in the area and harbour an incredible diversity of life. Cold water corals have been known to scientists since the 18th century, but their abundance in the deeper waters of all the oceans was startling. The Rost Reef, the largest cold water coral reef so far known, is 40 kilometers long. That's twice the size of Manhattan, and was only discovered in the year 2000. It forms part of a chain stretching from the tip of Norway across Europe to the coast of West Africa. Cold corals are very slow growing. Individuals can be up to 1,800 years old. Many reefs began forming at the end of the last ice age. Yet, just as scientists are beginning to map these corals and discover their significance to the marine world, so they are also charting their destruction. The most visible evidence points to the fishing industry and the widespread practice of bottom trawling with drag nets.
We very soon documented the damages, and it is especially on the trawling grounds. You know, the bottom trawls, it's heavy gear, and the reefs and or the coral colonies is very fragile. They're easily damaged. So it was quite obvious that this was an activity that couldn't go on.
The research vessel GO-SARS is a survey ship belonging to the Norwegian Institute of Marine Research. The institute advises their government on all matters relating to the marine environment. Today they are leaving Tromsø to undertake a survey for cold corals off the northern coast of Norway, deep inside the Arctic Circle. Fishermen have reported reefs in the area. If the reefs do exist, they will be north of any previously known coral grounds. The search is on. Jan Helge Fosse is leading the expedition.
And first of all, I'll just show you what kind of area we are going to. You know, Tromsø is down here. We will come up like this, cross the Lebih, and we go straight up to this area north of Sørøya. We have information that there are coral reefs in this area and also down here. This framed part is the conflict area. We have much reports from fishermen that we have a lot of coral fields, but also damages because of fishing.
Searching for reefs in an entire ocean is like looking for a needle in a haystack, so the local knowledge of the fishermen is vital. But given the amount of bottom trawling in the area and the coral's fragility, will the crew find their new reef or its smashed remains? Bottom trawling involves scouring the seabed with huge nets 60 meters wide, held apart by these metal boards, each weighing up to 5 tons. Under the sea, heavy ground rollers keep the net on the bottom. Like a plough, the trawl boards dig a furrow through the sea floor. Trawling in deep waters is the most destructive. Many organisms living here are slow to grow and slow to reproduce. The orange roughy, seen on many a dinner plate, can live for over 200 years. Cold water corals are found throughout the world, even in tropical waters and the high seas. These pictures show deep water corals from Hawaii, Alaska, New Zealand, and even the mid-Atlantic ridge. Many countries are still unaware of reefs in their waters, as only the developed countries have the resources to map them. Off the coast of Miami, the Oculina cold coral reefs have been studied since the 1970s, using the revolutionary Johnson Sea-Link submersible. One of these reefs was the Canaveral.
My first time that I saw the reef, it was incredible because you're on a flat sandy bottom and it's kind of eerie. I mean, you have some light, but it's kind of twilight, kind of eerie blue. And then you just saw this big white structure looming off the bottom, about 30 meters tall, covered with these breeding aggregations of scamp and gag grouper. So it was an awesome time to see that, you know, to know you're the first person ever to see that. When we first started lockout diving, these fish were right in your face. I had a table on the bottom to do a growth study of the coral, measuring the coral with a pair of calipers. And this big 100-pound grouper would come up and grab the calipers out of my hand, and he's sitting there with this ruler sticking out of his mouth. And I grabbed it back, and we kept going back and forth, and I had to push him out of the way. It was like a big Labrador retriever, and it's like the Garden of Eden. Once we stop hunting them and they lose the fear of us, they're just all around you, and it's wonderful.
In 1984, 238 square kilometers of the southern reef area was closed to bottom fishing, but the northern area was left open. John Reed was last able to dive on this section in 1985. In 2001, he returned.
So in 2001, I went back to the Canaveral Reef, expecting this thriving, beautiful reef, and it was devastating. It looked like a steamroller had gone through. You still had this 20-meter tall mound, but every piece of coral was broken into pieces the size of your finger. There was nothing standing. It was just crushed. There were no fish. I mean, I was heartbroken to know that we did that, humans did that, just for a plate full of shrimp. It was ridiculous. And they did it legally. You know, we're allowing that in this day and age to people to trawl living reefs. Why? It's stupid.
Corals are colonies of tiny living creatures called polyps. The tentacles of cold water corals capture passing organisms such as plankton. They are then drawn into a central mouth to be digested. The reefs they build consist of their branch-like skeletons. The living coral polyps sit at the end of these calcified branches, and although growth is slow, over time deep water forests are formed up to 30 meters tall. They provide excellent hiding for juvenile fish and draw larger ones in search of prey. The predominant species in the northern waters are Lophelia, a hard white coral that grows in bush-like structures, and Gorgonia, soft pink corals. As the GeoSARS approaches the survey site, the crew's first task is to make a multi-beam map of the suspected coral area. The multi-beam system utilizes sound reflections to build a real-time map of the seabed.
Now we are performing a first crude multi-beam mapping on the interesting area. The target is a deep ridge where we think that some of the reefs are located.
With the target identified, the ROV is prepared for diving.
So this is the ROV Atlanta that we are using on this cruise. It has a depth rating of 2,000 meters. And the equipment we have here is we have 4 high-intensity discharge lights. We also have a camera where we can move the camera around to see what we want. We also have a manipulator arm that we can use to take samples from the seabed or operating.
The ROV is launched through the side of the ship. It's the first dive this voyage, and with the prospect of finding the world's most northerly reefs so close, everyone crowds into the control room to get a better look. There's just a single data cable linking the ROV to the mothership, and with the craft as yet untested on this trip, it's a tense period. As the ROV begins its descent, expectation mounts. The mound is about 200 meters directly below the ship. The first sightings are not good.
Now we have got down to a place with potential coral mounds. And what we see here, it is only coral rubble. And it's trawled down to small pieces. We have so far seen no live corals. It's completely smashed.
It doesn't take long before the cause of the problem becomes apparent.
But already after some seconds we see the first lost net in the area.
As the ROV gets closer to the centre of the mound, some corals are found, but not the pristine reef they had hoped for.
This gear then, according to the information from the seamen, from the crew on board GeoSARS, they guess that this gear is about 20 years old, because this kind of trawl door went out of work 20 years ago. This is most probably showing a trawl track through the corals, perhaps made by the trawl board.
Further on, the team discover the remains of what looks like the ground gear from a trawl net. It seems irrefutable evidence, but what do the fishermen say? In Tromsø, we asked the Fishermen's Union how the trawlers operate in the coral areas.
The corals can be 13 or 14 meters high, so it's not possible to trawl over. But if they slowly eat in from the edges, they can damage the corals little by little.
But do they support a ban on fishing the coral grounds?
I think it's split. Those who use trawls seem to care less about this. They get good catches if they succeed in trawling through the area. It's different for those who use stationary gear. It's not used in the reef, as we lose the gear.
Fishermen using small gear are the most vulnerable to snagging and losing their nets, so tend to fish away from the reef. The Norwegian Coral Act of 1999, amended in 2002, protects all coral reefs in Norwegian waters from intentional damage, with bottom trawling now banned from 5 specific reefs. But Norway has the longest coastline of any European country, its national waters extending 200 miles into the sea, so policing the reefs is not a simple task. One solution adopted in the last 10 years throughout the North Atlantic fishing area is the Vessel Monitoring System, or VMS. The VMS automatically reports a vessel's position and speed, but its purpose is vessel location for fish quota inspections, not to identify illegal trawling operations on reef areas.
There have been no prosecutions to date based on VMS data that I'm aware of. In the United States, there's been one. I think there are problems to do with the agreement under which the fishermen entered into the VMS program. I think the fishermen agreed to send the governments these data on the positions of their vessels so that they could protect their interests and stop other nations fishing in their waters. Now, scientists like myself are saying, well, we can use it for all sorts of other things, like the protection of seabed habitats. And that's not what the fishermen originally signed up to, so there are issues to do with that in terms of data protection.
The North East Atlantic Fisheries Commission manages the exploitation of international waters in the region. We spoke to Kjartan Hoydal to find out what is being done to protect corals in these areas.
One of the things that hasn't really been discussed politically is how much do we want to close. Greenpeace has recently suggested that 40% should be the aim. I would have thought most governments think about something like 5 to 10%.
But why is there a delay in protecting coral reefs?
The problem is it should be based on scientific evidence. The scientists are not in a position yet to give a precise answer as they do on, say, catch levels and what have you.
The science is progressing apace. In December 2005, scientists from around the world traded information at the 3rd International Symposium on Deep-Sea Corals held in Miami. But some think we shouldn't wait for the science to be complete before protecting the reefs.
If there are areas where clearly the bottom trawling can take place in a sustainable manner without adverse impact, then the trawling can resume. But until we have these areas mapped out and have a better understanding of the biogeographic patterns of coral distributions in the deep sea, allowing trawling in areas simply because we don't know yet whether corals are there or not or how many or exactly where they are isn't good enough.
Even with agreement on the percentage of reefs to be closed, vessels from countries outside the Commission's jurisdiction fish whatever and wherever they like.
Our main concern at the moment is what we call IUU fishing, that there are vessels which are under flags like Panama, Georgia, Cambodia, or whatever you have, which are not bound by our rules because they're not parties to the agreement. They can do whatever they want. They can fish in excess of quotas. They can trawl over areas that shouldn't be in protected. We can't do anything about it.
Jan Helge and his team believe they have another weapon in the fight to save the corals. The team have developed a CamPod system that can bring back high-definition pictures of the corals. It comprises a giant leap in picture quality.
We know that it's very important to get our results out, first of all to the government and the managers, but also to the public. And that's why we use a lot of videos. It's telling more than 1,000 words, of course, when you see these fantastic areas down there. Then people, they intuitively understand that this must be protected. I never heard a person here in Norway, after looking at the videos and getting a little information, that object protection. I've not heard it. So, I mean, information, it helps and works.
Today is the first time Jan Helge's team will use the high-definition camera on a coral survey trip. They hope it will help them find the intact reef they still feel is out there.
Now we are close to the top of the reef, but we have seen still a lot of damages here, as we saw in the front of the reef, a little lower to the north. However, we have more live corals here than we saw earlier. Still we see signs of fishing activity, like nets and trawl tracks. So it is quite impacted also here.
Further on, there was a surprise in store.
Yes, here we are really nice. Now this is a fantastic area. A colorful landscape. Sometimes it's really breathtaking because it's so fantastic that deep down in the dark here, facing the Arctic, we have these wonderful, colorful scenes. It's amazing. It's almost unbelievable. And as far as we know, this is the northernmost intact Lophelia reef complex.
Finding the reef further increases the known distribution area of these corals and emphasizes how much there is still to learn.
It's a little difficult to find a landing place here. It is steep, and we don't want to damage the camera or get scratches on the lens. Yes, now we have landed, and it seems that we got a nice and interesting place to take some close-ups. It's beautiful. Oh, fantastic colors. Pink gorgonian. And here you can see the complex three-dimensional structure that these reefs represents for fish, for example. The ling loves to go in between the coral heads and hide itself. There's a whole new world that's opening for us, and we can have close-up that was unthinkable only last cruise because of the new camera system we have on board.
All the animals, the fish, the sponges are just incredible. It's like going to Mars and seeing something living there that nobody's seen before. But this is in our backyard. It's not Mars. This is just a few miles offshore. Not that deep, 1,500 meters deep. It's not that deep. It's right here. Let's protect it first. Let's protect it before we destroy it.